I know you guys don't like word problems, but here we are. It's down to the word problems. Dun, 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 dun. Okay. Well, how? You weren't going to have to do the math of the word problem. So we had to build up to it. All right. So up first, we have solutions and applications of right triangles, not just any triangles, which is 2, 5. 2, 4 is specifically for right triangles. Okay. So significant digits. Do y'all remember talking about sig figs in your science classes? Okay. Significant digit is a digit obtained by actual measurements. Okay. The significant digit in the following numbers are identified in color. So I start off here, 408. That is significant. I need to know the whole 400, the 4, the 0, and the 8. All those digits are important. 21 and a half, 21 and 5/10, all significant digits. 18, $18, 18 and 0 hundredths is significant. 6 and 700 thousandths, significant. However, notice here, when I get to this right here, these are not significant digits. The significant digits are 25. And the reason being is that I can use scientific notation, right? And come down to these values, right? Does that make sense? Y'all remember scientific notation? So it would become 2.5 times 10 to the negative 3, right? But my significant digits are 2 and 5. Same thing here. Significant digits are 9, 8, 1, 0. 0 is not here. The 0 in the tenths place is not significant. And then 7,300. The 7 and the 3 are significant. Again, think about, can I write that as scientific notation? If I wrote that in scientific notation, it would be 7.3 times 10 to the third. Okay, so let's see. So when I say scientific notation, do we remember? My pen is weird lately with the new computer. It doesn't like automatically start writing anymore, and I don't know why. There's weird things. But we went to the right. So scientific notation, this would be 2.5 times 10 to the negative 3. On this one, we're going to the left. 1, 2, 3. So this would be 7 and 3 tenths times 10 to the third. Does that ring bells? I remember seeing this. Okay. Same thing here. We're going to the right. So we're at 9 810 thousandths times 10 to the negative 2. Okay. Yes.
Why are they significant?
They're significant because with the values left standing, I can still determine a measurement. I can still say this is the quantity without having to have those necessary zeros. It's the best way I can answer it. So like it doesn't change the calculations. It's not going to change the calculation drastically. That's literally what I'm just saying. So
Gonna get experience with these?
Yeah, we're going to talk about it. And we're going to talk about it in terms of our angles and degrees. Okay. So when I'm asking for rounding to the nearest, it's a specific number of significant digits I'm expecting from you. Does that make sense? So if you are asking to be rounded to the nearest degree in this situation, so I'm looking for a degree, I'm going to need 2 significant digits. So 62, 36, the rest I don't need, right? If it says 10 minutes or nearest tenth of a degree, then you're looking at your minutes rounded to the nearest tenth or your angle rounded to the nearest tenth. And that's going to be an example of 3 significant digits. Okay. Minutes or nearest hundredth of a degree. Again, I have my minutes as they are. And then the degree is rounded. Or here in this case, I have more in my decimal. So it goes from the tenths to the hundredths. So this is 4 significant digits. And then 10 seconds or nearest hundredths of a degree. Now I have more significant digits that matter. And that's what it's looking at. Remember, digits make up numbers. Numbers are not digits. Okay, numbers are made of digits. So for example, if I have a 1 and a 0, Those are my two digits. They can produce two numbers, right? A 1 and a 0 can either be 0, 1, that's 1, or 1, 0, which is 10. Digits make up the number. So you're literally counting the number of digits that are being utilized. Okay. Again, it's just more of making sure you're rounding correctly when discussing angle measurement and what the problem's asking of you. Okay. So a lot of times you're like, I know I did the math right. Why is it counting it off? Well, in the system, it's saying, okay, well, we asked for degrees and you still wrote 62.5. You gave me an extra digit that I didn't need as far as rounding to nearest degrees. Okay. That would be the best example of it. Okay. All right. So to solve triangles, to solve a triangle means to find the measures of all the angles and all the sides. So if you're asked to solve a triangle, you're solving for all of the unknowns, every angle, every side. Okay. So for example, here, key things to remember when you're solving is that angles are across from their opposing sides. So angle A is going to be across from side A. Angle B is going to be across from side B. Angle C is going to be across from side C. Location matters when you're describing, okay? The other thing to matter is that the size of the angle. If angle B is your larger angle, then side B will be your larger side, okay? They correspond to each other in measurement and location. Got it? So, and just capital letters are angles, lowercase letters are sides. You remember that from geometry when labeling? All right. Typically, especially when you're working with this company, well, this textbook, your C is always your hypotenuse. Okay. They're going to always label your hypotenuse, or when they refer to the hypotenuse, it's always going to be angle C. Well, angle C will be the 90 degree and the hypotenuse will be side C. So keeping that in mind, let's dive in. Here's our first angle, our first triangle, and we're going to solve for all of its unknowns. So the unknowns that we have are, we do not know side B, we do not know side A, and we do not know angle B. So we have three unknowns to find. Agreed? All right, it tells us that angle A equals 34 degrees and 30 minutes. Knowing what angle A is, could we solve for angle B out of the gate? I can't, right? Out of the gate, we can solve for angle B and be done with that one.
Wait, so why? Oh, never mind.
What I do wrong? I always solve for the easiest thing first. And so in this case, it's going to be angle B. To solve for angle B, we know that it has to be 90 minus 34 degrees. They're living their best life. And 30 minutes. Do remember how to subtract with there we go. So this is going to lead us to, we have 89 minus 34 degrees. And then we'll have plus 60 minus 30 minutes. So what are we left with for angle B? We have 55 degrees and how many minutes? 30 minutes. Angle B is done. Easy enough? All right, now we're down to finding A and B. So sides A and B. When you're solving triangles, you want to use your given information as much as you can. So when I'm looking at side A, I have angle A and side C. What's the relationship between angle A and side A? They're what? They're across from each other. They're opposites, right? It's the opposite side, and I have my hypotenuse. Does that make sense? So I can use sine of this to solve for that. We're going to switch colors. So if I'm looking now for side A, we're going to use sine of A. And the sine of A equals your opposite over your hypotenuse. Okay, so plugging in what we know that sine angle A is 34 degrees and 30 minutes. equals, and we're looking for side A over our hypotenuse, which is 12.7. Okay, what would I need you to get A by itself? Multiply by 12.7, good job. So to find A in the calculator, I'm typing A equals 12.7 times the sine of 34 degrees and 30 minutes, which we will convert in the calculator. Is that cool? All right, to the calculator. All right, Sylvie, where art thou? Here she is. Gonna turn her on. I'm gonna clear. I'm gonna make sure my calculator is in what mode? Degree mode. So we're gonna go to mode, go from radians to degrees. I'm in degree mode. I'm gonna convert this. So we have 34 plus 30 divided by 60. I mean, I didn't want to convert it. I'm gonna write it in there, sorry. 12 and 7/10 times the sine of 34 plus 30 divided by 60. And I'm going to hit enter. So what I do? Oh, and we hit enter, and we get that we are 7. And I'm going to look, we're rounding, we have 3, 7, and 19. 7 and 19 inches. Because when I look, everything else has 3 significant digits. So I want to follow the 3 significant digits. Yes, for the minutes. Mhm. Did you switch your mode? Did you write 12.7?
Why did you do that? I don't know. She didn't do it like that. So she didn't. She did 34 plus 30 divided by 6. Oh. You didn't fill in the 6. She did divide by 6. But she didn't add the degree in the minutes. She just did 34 plus 30 divided by 6. Oh.
To me, that's faster.
Why is it 3?
If you look at the given information, the C, and they're given 3 significant digits, right?
Yeah.
So then my result is also 3 significant digits. Got it? All right, was that terrible? Yeah. All right. Now we got to do C. What is the relationship to B? What is the relationship to angle side B and angle A? They're what? They're adjacent. So which trig ratio am I using? Cosine. So to find B, we're doing the cosine of A, which equals adjacent over hypotenuse. So we're going to plug in what we know. We know the cosine of A, which is 34 degrees and 30 minutes, equals your adjacent, which is B, over your hypotenuse, which is 12 and 7/10. So just like before, in order to find B, what do we have to do? Multiply. So 12 and 7/10 times the cosine of 34 degrees and 30 minutes equals what? I think so.
So why is that not 3?
It
Oh,
is. Is it not?
Yeah.
So 12 and 7/10 cosine of 34 plus 30, 3 over 6. Oh, I'm writing the whole thing. Let me the sign find. My pen.
Sure. Yeah, I got like.
Simplify.
What is six big?
Significant figures. If you're, yeah, most like if it's the slang in science, they don't say significant figures. So B equals 10 and 5.
Oh, wait, if we did the diagram here. Oh.
Because once you have A,
Right.
you could do Pythagorean. However, how we solved all of our missing pieces? Was it terrible?
Yes,
Why was it terrible?
these significant figures.
You're looking at it.
It doesn't make sense in my
We
brain.
always have to have three.
You pay attention to your given information. So if your given information is giving you a certain number,
Three digits,
Oh,
the 34 and the 30.
let's go back to our table. So remember right here, we talked about in our example where it says if you're at 10 minutes or nearest 10th of a degree, when you have this is 3 significant digits. The 52, the 3, that 0 is not counting as a significant digit.
Why?
What if it's one?
If it's a 1, then it would be a significant digit. But when it's a 0 there, it's not. So notice here, when it became something other than a 0, it down says how many significant digits are represented in my degrees and my minutes.
Oh, okay.
4, right?
So as long as there's a 0 within the.
That makes
minutes
it
and
3, yeah.
seconds, it would make-
So
okay.
like here, this is only 5 because in my seconds it has a 0.
Okay.
Yeah? Okay. All right. So just remember, when you are solving, you could have done B by Pythagorean theorem, side B by Pythagorean theorem. But when we're solving, we want to make sure we're using the given information as much as possible. So the less you created answers, then possible. This also helps. What if your answer was wrong? And then you used your answer to find the rest of your answers instead of going back to the original information. So just be mindful when you're using your generated answer versus the given information, okay? All right. Now this time, we are given only our sides and no angles. So we now, well, we have 90. But now, because we're looking for our angles, does anyone remember what we're doing? Find an angle. The inverse, there we go. Good job though, good job. All right, so here we're going to find the inverse. If you want before, the easy thing to find here is what though? B is going to be our easiest. So based on what we have for B, we have our hypotenuse. B is just going to be the simple, good old Pythag, right? We're going to use Pythagorean. Agree? Instead of adding with Pythagorean, we are subtracting because it's not the hypotenuse. So it's going to be our C squared. Yeah, thank you. Minus our A squared. So B squared equals C squared minus A squared. We're going to plug in what we know. So to find B is going to equal the square root of 53 and 5800 squared minus 29 and 4300 squared. How many significant digits are there?
4.
4.
Ooh, okay.
Okay.
I get it now.
Okay. So we're going to go ahead and put it in. Are we good? All right. So we're going to plug this into the handy dandy Sylvie. Open Sylvie. And I'm going to press second. Oh, come on, Sylvie. Second square. And we have 53, 58 squared minus 29 and 43 squared. And we hit enter. And we get perfect. And it's centimeters, right?
Is that it? Or-
That's, we gotta find our angles now. We did the easy part first. Now we're on to the angles. Good job. 44.77. Is that what you got? Perfect. All right, so let's just go ahead and do angle A. So angle A, I know it's opposite and it's hypotenuse. So to find angle A, I'm using what? The inverse of, I have my opposite and hypotenuse. Opposite and hypotenuse. Sine, we're doing the inverse of sine. Okay?
I see.
Because I'm given my opposite side and my hypotenuse. So we're gonna be using sine, which is opposite over hypotenuse. Because you don't know the angle. So angle A equals the inverse of my opposite, which is 29 and 43/100 divided by my hypotenuse, which is 53 and 58. Agreed? Okay. So we're gonna press second sign, and we're putting in 29 and 43/100 divided by 53 and 58. And we hit enter, and we get 33.32 degrees. So it's approximately 33.32 degrees. Do you guys remember how to convert it?
So what?
If I wanted to have it in
No.
degrees and minutes? No, if I wanted to convert this to degrees and minutes, what would I do?
I have to go back in my.
Divide. No, I don't know. I just jumped right.
Huh? You're gonna multiply. What would you multiply by?
60 and 30.
60 and the
3600.
the decimals.
Yes.
You multiply 60 times your
So
decimals.
take the 33, that'll keep,
Mm-hmm.
and then you take the 0.32, multiply it by 60. And then you get your other number.
There you go.
And then you multiply the decimal, of that other number by 60.
Okay, so I just wanted to make sure we remembered. All right, I'm going to subtract 33 from this, just so I can have an exact decimal. So you have your decimal, right? And you're gonna multiply that times 60, and that gives you your minutes. So how many minutes would it be?
19.
19.
Oh, and then the 99 minus. You, okay,
Yeah.
I remember.
Do we remember?
Yeah.
So this is approximately 33 degrees and 19 minutes.
So, yeah, okay, and then you do
And if I wanted to keep going to find the seconds,
the last decimal.
exactly. So if I wanted to find the seconds, I would take this minus the 19 and whatever is left. Oh, I didn't write it minus the 19, guys. So I would take this minus the 19. And what's left of that, I would multiply by 60, and that would give me my seconds. So it'd be, that's going the other way. When you're going to degrees, you divide by 3,600.
Times 60?
Mm-hmm.
Oh, because 19 minutes.
Yes, because you already took care of that part, right? And then you're just left with that left. So, but we only needed 4 significant digits. So did I need to go into seconds? Nope, I didn't. But if I did, that's what I would do. Does that make sense? All right. Oh. For the seconds, I got 1. I got 1 second left. Oh. Well, the 0.5 would round it up to about 2 seconds or 1.5 seconds, 1 second. All right, but just wanted to make sure we remember how to do it. This is fine for me. Oh, pen doing weird things. We got that part, right? Okay, then we're good to go. We're golden.
Yours to make us turn us a minute.
I don't know. That's why I wanted to make sure we remembered it. Because it made a note in our instructor guide to mention minutes. So I just wanted to make sure that you remembered. So I mentioned it, right? I recall. We brought it back. All right, B. So B, what's the relationship to B with the information we already have? We know it's adjacent and it's hypotenuse. We know it's adjacent and it's hypotenuse.
2
Cosine.
minus 33.
Remember what I said? We want to use our given information every single time. Okay. So we're going to do the cosine inverse to find B. So B equals the cosine inverse. And it's the same numbers, 29 and 43 divided by 53 and 58.
So if we did regular cosine, if we find side theta,
Yes. When you're using regular cosine, that means you already know the angle measurement. Inverse is saying you don't know your angle measurement. And we don't, so. Second inverse, and we have 29, 43 divided by 53, 58. And we get 5668. So we have 5668 degrees.
6,
And then, there we go. So if I wanted to do it, I'm gonna subtract the 56, and I'm left with those numbers, and I'm gonna multiply them by 60.
subtracted this from 90. Would be 90 minus what, like,
I said yes, in
oh,
theory, but we're encouraging to always use the given information, not your calculated information. Okay, let's say, for example, you got A wrong. And then you use A to get B. What did you just now do with B? You also got B wrong. So that's why it's recommended to keep encouraging you to go back to your given information. If it's multiple choice, you can swing it, but just oh, where we at 40 and 97? 40, 56. I got a potty. It's about that time for me to go. 56 degrees and how many minutes? 41, yeah, because the 9 rounds up, right? And now we have all of our unknowns. What's wrong with it? I thought we did really good. I didn't think it was that terrible. You just wanted to complain. That's pretty much it. And then we hit the word problems. I know, word problems, still no. Okay. So the word problems, that's 2.4, focus on, are called angles of elevation and depression problems. So we got to make sure we understand what angle of elevation and angle of depression means. So your angle of elevation is saying that you're on a horizontal part and you're rising upward. So the horizontal, the flat, the ground, and your angle is extending to a ray above it, okay? Angle of depression is that you're above, the horizontal is at top, and your angle is heading towards that point now, okay? So that's the difference, angle of elevation, angle of depression. Do you see the difference between the two angles? Okay, I hope so. All right. Be careful, both the angle of elevation and the angle of depression are measured between the line of sight of a horizontal line. Okay, you're still using horizontal line, all the same. Just make sure you're interpreting it correctly from the information. This is important because the first thing you want to do when given a word problem, especially a trig word problem, is draw a sketch. draw a sketch and label all that's been given to you. Okay, drawing the sketch correctly and accurately is going to be critical to your solution. And then you're going to use the sketch. Once you create your sketch, it's just like what we did, finding our unknowns. Does that make sense? But you have to get to the sketch part in order to do that. Okay. So let's look at our example here. We're start off easy. Okay. All right. At a point A, 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. Find the height of the flagpole. So as you can see, it says that I had elevation. So I knew I had a horizontal on the ground. I elevated 26 degrees and 40 minutes up to the top of the flagpole. So I measured my 123. I have my angle. Can I solve for A? What is the relationship between angle A, side A, and my given information? I have my adjacent and what's the relationship between these two? Angle.
I mean, not on you, you're opposite.
I have my opposite and adjacent. So what trig ratio am I going to use to help me navigate this? Tangent. We're going to be using tangent to find. So we know the tangent of A equals my opposite over my adjacent. So plugging in what we know. A is what?
Hey.
26 degrees and 40 minutes, right? No, the measurement of A is, all right. And then our opposite is our unknown, side A, some amount of feet. And our adjacent is 123. Can I solve for A? How do I solve for A? Multiply, perfect. So we know that A equals 123 times the tan of 26 degrees and 40 minutes. Okay. Huh? Did you get a big number? All right, so I'm going to go to my handy dandy calculator. Here's Sylvie, back at it. Ready to type 123 times the tan, 26 plus 40 divided by 60. And I get 61.8. Why am I going to write 61.8? How many significant digits are given to me? 3. So we're going to write 61.8 feet. All right. That is our baby word problem. How do we feel about the baby?
That's the baby.
That's the baby.
Uh-uh.
Don't look at me. You just got one more to do.
Then we got 2.5.
We'll take a stretch and a bathroom break before 2.5.
Just because you need to.
Doesn't matter. Doesn't matter. Why we're doing it. All right. Was that bad? Oh, whatever.
Yeah.
All right. Here we go. It says here, from the top of a 210-foot cliff, David observes a lighthouse that is 430 feet offshore. Okay. Find the angle of depression from the top of the cliff to the base of the lighthouse. All right. So at the top of the cliff, he observes a lighthouse that is 230 feet from the shore.
Is it dancing?
I don't know. You tell me. It wants us to find the angle of depression. So we're looking for A. Okay. Now, using this triangle, well, we're not looking for angle A. We're looking for the angle of depression. Do you guys remember alternate interior angles, things like that from geometry? Okay. And this is an alternate interior situation. So to find the angle of depression, we're gonna have to find angle B. Does that make sense? Yeah. Okay. So again, this is an alternate interior angle. So that we're going to be using angle B to find our angle of depression. Is that cool? So if I have angle B, what are the values that I have? I have its opposite side and its adjacent. I'm looking for the angle. So what am I doing? The inverse. So to find B, we're gonna have to use tan inverse. Does that make sense? So angle B equals the tan inverse, and tan means opposite. What's my opposite? Over my adjacent, which is 430, and that's it. Okay, so we go to our calculator. Perfect. So second, tan 200. I'm just gonna write 21 divided by 43 because that extra zero is gonna make it. And we get 26, just 26 degrees. We get 26 degrees is our angle of depression. Oh, sorry. All right. Terrible. That's it for 2.1. It wasn't. Y'all are just crybaby. All right. So the biggest difference here is for angle of depression, instead of using the angle on the outside, make note that you're going to be using the angle on the inside, the alternate interior. Okay.
Well, I- pressure used to be so much less.
Oh my god. Why is there 9
So.
slides? The last one was 6. The whole thing was 6. I didn't do it already.
Really?
And I have